Hello, today we're going to look at derivatives of sine and cosine. If you want to see the algebraic approach as to why the derivatives of sine and cosine are what they are, I suggest looking in the book. I'm just going to gloss over them and just tell you what the derivatives are. So if I differentiate sine of x, I get out cosine of x. And if I differentiate cosine of x, I get out negative sine of x. So whenever I differentiate one of the co-functions, cosine, cosecant, cotangent, it's going to be very similar to the non-cos, the sine, the secant, the tangent, except that it's going to be one of the main differences is that they're negatives. So the derivatives of all the co-functions are negative. The derivative of all the non-cos are positive. And what we're going to do is we're going to focus on a special form of the chain rule that we used in Calc 1. So in Calc 1, we only had polynomials, so our chain rule looked like a function raised to a power. So we differentiated the function being raised to the power as if it were just a variable being raised to the power. So nu to the n minus 1, and then we multiplied by the derivative of that function, the u prime. We're going to look at the very generic form of the chain rule, which is just a composition of functions. So the derivative of f of g of x is the derivative of the outside function applied to the inside function times the derivative of the inside function. So we're going to go over this on the next slide with 4 different examples. So differentiate the following. Sine of 2x. So I have sine of a function. So the first thing I'm going to do is differentiate sine of u. And I'm going to get cosine of u, but u is 2x. And then I'm going to multiply by the derivative of the function that sine is being taken of. So the derivative of 2x, which is 2. And then we like to have our coefficients out front, so I'm just going to rewrite it as 2 cosine of 2x. The next example, cosine of a function. So cosine of x squared, I can think of that as cosine of u, where u is x squared. So the first thing I do is I differentiate cosine, which will give me negative sine. So I have negative sine of u, so negative sine of x squared, and then I'm going to multiply it by u prime. So the derivative of x squared is 2x. And then again, I'm going to clean it up and I'm going to put that out front. So I get negative 2x sine of x squared. And now I'm looking at y equals cosine cubed of x. So the 3 on the between the s and the parentheses is the same. Whoops. Let me put my marker back on. Is the same as cosine of x all cubed. So not cosine of x cubed, but cosine of x cubed. So this is a function being raised to a power. So I'm going to first treat it as u cubed, and the derivative of u cubed would be 3u squared. So I get 3 cosine squared, and then I'm going to multiply it by the derivative of the function that was being cubed, which is cosine. So I get negative sine x. Make sure you're really careful. You put this in parentheses. If I don't have parentheses, then what I have is 3 cosine squared x minus sine x. But it's not subtraction. It's multiplying by a negative. And again, I'm going to pull out my coefficients and make it negative 3 sine x cosine squared x. And then my next example is y equals the square root of sine x plus 3. And again, this is a function being raised to a power. Remember that the square root I can rewrite as sine x plus 3. Whoops. Can't really see that too, to the 1/2. So remember, the square root is to the power of 1/2. Okay, so we're really going to have to remember these rules of exponents in this class. So again, I'm going to treat this as, trying to make that a plus sign, there we go. I'm going to treat this as a function being raised to the 1/2, so u to the 1/2, I differentiate that by bringing down the 1/2 and raising my u to the negative 1/2. So my derivative starts off as 1/2 sine of x plus 3 to the negative 1/2. And then I multiply by u prime, the derivative of sine x plus 3. The derivative of sine x is cosine x, and the derivative of 3, remember from Calc 1, is 0. And again, I'm going to clean this up. I'm also going to put back what to the negative 1/2 means, just to make it look a little nicer. So I've got cosine x on top. The 2 from the 1/2 goes in the bottom of my fraction. And remember, the negative 1/2 power means A, the square root, because it's 1/2, and B, 1 over the square root, because it's negative. So I get cosine of x divided by 2 times the square root of sine x plus 3. Okay, so that is a refresher on the chain rule and also using sine and cosine. And then the next thing we're going to look at is using sine and cosine with the product and quotient rules. So our first example with that is y equals x squared times sine of x. So we've got a product here, x squared times sine of x. So we need to remember what the product rule says. The product rule says that if I've got u times v, then the derivative of that is u prime v plus v prime u. So I take one of my functions, I differentiate it, I multiply it by the other function, and then I switch and add them together. So I'm going to start by differentiating x squared, which is 2x, times the other function, so 2x times sine x, plus x squared times the derivative of sine x. So the derivative of sine x is cosine. So I'm going to add cosine x times x squared. And again, I'm just going to clean it up. We tend to put the trig functions at the end. So I'd write this as 2x sine x plus x squared cosine x. The next example is going to be the quotient rule. So y equals cosine of x divided by x plus 1. And if we remember the quotient rule, it says that if I'm differentiating u over v, I get u prime v minus v prime u all over v squared. So I'm going to start with u prime v. The derivative of cosine is negative sine times v x plus 1. And then I'm going to subtract the derivative of x plus 1 times cosine. The derivative of x plus 1 is just a 1. So I'm going to subtract 1 times cosine of x, divide it by v squared. And then again, I'm just going to clean it up. So I get negative x plus 1 times sine x minus cosine x over x plus 1 squared. So let's try another product rule. Y equals sine x cosine 3x. So I start with the derivative of sine times cosine 3x. So cosine x cosine 3x. And then I'm going to add to it the derivative of cosine 3x times sine x. So the derivative of cosine 3x involves the chain rule. So I get negative sine of 3x times the derivative of 3x, which is 3, times the original sine x. So again, I get a negative because the derivative of cosine is negative, and then sine of 3x because that's the derivative of cosine, 3 because that's the derivative of 3x, and then sine x from the original sine x. And then again, I'm just going to clean it up. We get cosine x cosine 3x minus 3 sine x sine 3x. And then lastly, we're going to do another quotient rule. So y equals x cubed over sine of x squared. So I'm going to start by differentiating x cubed and multiply it by my denominator. So 3x squared sine of x squared. Then I'm going to differentiate the denominator. So again, in here I've got sine of a function, so I have a chain rule. So I'm going to subtract the derivative of sine, which is cosine, so cosine of x squared, times the derivative of x squared, which is 2x, times my numerator, which was x cubed. And then I'm going to divide it by my denominator squared, so sine squared of x squared. And then lastly, I'm just going to clean this up. And we get 3x squared sine of x squared minus 2x to the fourth cosine x squared. So I'm combining those two to get my 2x to the fourth there, and then still dividing by sine squared of x squared. Okay, so try out some of the homework and just let me know if you have any questions.